We learned how to create snapping points when we are not satisfied with the ones shown to us. We did 2 examples of that in that video, when we need to use general joints. And you can see general joints places the thing in the final position as well as making the kinematic relationships. The snaps we get depend on several factors: the 3D solid creation method, extrusion, loft, sweep, revolve, etc., or the 2 sketches that produce the object: symmetry and revolution points and plane. So we could also use construction points and planes to get snapping points. In the above piston, none of this gave us the needed reference. Similar problem at the back of the crank. Needed to create reference points, which we did. Now, the next thing we want to talk about is location of entities. Working thus far, we have created several entities. We've created sketches, bodies, construction geometry, snap points, joints, components, and etc. All these things are gathered into some containers. Some of the containers are components, some containers are bodies, and some other things. But sometimes you care where some particular entity is stored. For instance, imagine you need a sketch that created the body after you have transferred the body to another design. If the sketch is left in the old design, then you have no reference point. Most of the time you don't need them, but what if you do? So because of that, you need to know where your entities are stored. It's especially useful for joints. If you will see now that we can determine where our joints are kept, we can determine where the sketches are kept by doing some simple things. So the big questions are, does it really matter where these are located? What if a body moves? They move with components during an assembly operation. What if that process leaves the sketch behind? Can you need that sketch later? What if you replicate as in a pattern replication process? My first experience with Fusion 360 was that as soon as I replicated with pattern replication, all the assembly, all the joining were gone. So if you created 10 copies of your cylinder, then you have to manually replace those joints one by one by one in all those replicas. Is there a better way? Yes, there is a better way. Do you want to go through the process of recreating joints manually in a repetitive process? Of course not, if there's a way out. Now, the next set of slides will show what this way out is. We talk of copied components. Consider components here copied from a different design, like we did before. And if you look at the browser details in the new location, here is the browser detail for the copied objects. Notice that only the crank component has the sketches traveling with it. If you look very carefully here, you can see that the sketches travel with crank, but sketches did not travel with the connecting rod, nor did it travel with the pin or the rotor. No traveling sketches. The sketches were left where they came from. Now, can we modify this? Why are there no sketches for the others? Could you later need these sketches? Answer is yes, you may need them. So look at this assembly. Look at this. I opened this thing up. The connecting rod contains origin, bodies, but no sketches. The pin contains origin, bodies, but no sketches. The end contains origin, bodies, no sketches. The crank contains origin, bodies, and sketches. It's like arbitrary. How come we got the sketches in this, but we didn't get the sketches for the others? Is it arbitrary? It is not arbitrary. We can control where some of these things go. And the thing you need to look at is very important. The question is, where are you focused? Where are you focused? I can create a construction mid plane on the connecting rod by simply putting the focus on it. If I put the focus on it before creating the plane, you take the dot, you just go to the connecting rod and click the radio button. If you click the radio button, then it has focus. When it has focus, all the other components are grayed out to show that they are as good as if they did not exist. The only thing that exists right now is the connecting rod. That's why it's shown in full color, and the other things are grayed out, and you can forget about them. If you create any construction plane now, or any construction geometry, lines, axes, points, they are going to be stored with the component of connecting rod, because that is where focus was when they were created. If you do any sketch on this plane, that sketch will also be stored with the connecting rod, as long as the focus remains the connecting rod when that sketch was initiated. So the construction plane, as well as the sketch that falls into the list of entities inside the connecting rod, note that the other components are shaded out or grayed out. Look at the list of entities. See it more clearly on the next page. Okay, so this same picture we were looking at, but enlarged here. So it's nothing different, but you can see that here, what is shown in true color is the connecting rod and the construction plane that we have asked for. We asked for a construction plane to be a mid plane between two surfaces. So it is essentially cutting through, it's cutting through this in half. So joints and components. As we have shown, sketches, construction geometries can be placed where we like them to be by simply changing our focus prior to producing them. Bodies can be created anywhere, and placements can be changed by simply drag and drop. Same with components. Components inside other components can lead to unexpected behavior, so you have to be careful. Joints are at the higher level than the components. Joints at a higher level than the components do not occupy the pattern, do not copy in a pattern replication. So if your joint is at a higher level than a particular component, when you copy that component, it does not carry the joint along. That may force you to repeat the patterns when you need them. This manual step may be easy, it may become tedious. When you are doing it so many times, you become tedious and you might actually lose concentration and create errors. Pattern replicas. If this particular case, I try to create a pattern replication by just choosing this thing with a window. And I created 4 of them. And I saw that when I created 4 of them, it created 8 pins rather than 4. I was wondering where the remaining came from. The thing is that it chose a piston, which means it automatically chose the piston pin. Then it chose the piston pin separately. Therefore, there were 8 requested rather than 4. And you get some strange errors that you don't, and so you can get some unexpected result in pattern replication and some other copying processes if you do not arrange your components well enough. Even though we started late, maybe it's a good time on slide 22 to take a small break